Welcome to The Explainer. I'm your host, and today we're tackling a huge topic. We're looking at how the electric vehicle industry is basically attacking its final biggest hurdles. And they're doing it through two radically different infrastructure paths. We're going to look at some absolutely cutting-edge engineering and some super creative business models that are completely reshaping how we power our vehicles. So, let's get into it. Okay, let's kick things off with a question that hits right at the biggest pain point for anyone thinking about buying an EV. What if charging an electric vehicle took the exact same amount of time as pumping gas? I mean, that's the holy grail of the electric transition, right? We're not talking about those long strategic highway stops or, waiting around for a 45-minute coffee break. We are talking about rolling in, plugging in, and rolling out just as fast as you would at a regular old gas station. Well, BYD, the global giant in new energy vehicles, is promising exactly that. They're claiming you can add 200 miles of range, literally taking a battery from a 10% charge all the way up to 70% in exactly 5 minutes. 5 minutes. That is a massive game-changing claim. And it forces us to really look at how we're building our electric future and, honestly, the sheer physics required to actually make something like that happen. Here is our roadmap for today's explainer. 1. The EV charging hurdle. 2. BYD's flash charging revolution. 3. How flash charging works. 4. The real-world limitations. 5. Beam's off-grid alternative. And 6. 2 paths forward. Section 1. The EV charging hurdle. Waiting for the charge. Let's start with the big obstacle that both of these companies are so desperately trying to overcome. You see, the fear of waiting around is holding back nearly half of the market. According to recent survey data, 42% of UK car buyers consider slow charging times to be the absolute most significant reason not to buy an electric car. It's a deal breaker. Speed and availability, they're the ultimate prizes here. If you can solve the waiting game, you unlock a massive wave of global adoption. Which brings us to Section 2. BYD's flash charging revolution, a 1500 kilowatt brute force solution. BYD Group has rolled out what they call flash charging, and they're boasting the world's fastest mass-produced EV chargers. We're talking about stations delivering a massive 1,500 kilowatts of peak power. Just to put 1.5 megawatts into perspective for a second, that is literally enough power to run a small neighborhood. And it's being pushed directly into a single consumer vehicle. It's wild. BYD's marketing promise for their European rollout is super catchy. Ready in 5, full in 9, cold at 3. Basically, that means a 10 to 70% charge in just 5 minutes, 97% in 9 minutes, and only 3 extra minutes if it's literally freezing outside. Oh, and you might be wondering why they cap that rapid metric at 97%. Well, that's so the vehicle's kinetic energy recovery system can actually function immediately through braking, which lowers your overall energy consumption right as you drive away. Pretty clever, right? Now, to achieve these incredibly fast timeline milestones without making you, the driver, wrestle with some heavy, dirty cable dragging on the ground, BYD completely redesigned the hardware. They use a suspended T-shaped rail system that actually keeps the liquid-cooled cable up and off the ground. You just move a lightweight 2-kilogram zero-gravity cable laterally to plug in, and it doesn't even matter which side of the car your port is on. It's super seamless. Moving on to Section 3, how flash charging works, the 3 levers. So the absolute crucial question here is, how on earth do they push over a megawatt of power into a battery without completely melting it? Because as we know, fast charging inherently generates heat, and heat is the ultimate enemy of battery life. Well, it all comes down to basic electrical physics. At equal power, if you raise the voltage, you reduce the required current. Standard EV architectures run at about 400 volts, meaning pushing a megawatt would require a massive, heavily heat-generating 2,500 amps. But by cranking the architecture up to 1,000 volts, BYD drastically reduces that required current down to 1,500 amps. That means significantly less heat to dissipate during that intense charging process. It's just a really elegant engineering workaround. So BYD attacks this intense heat and battery degradation using 3 combined levers. First, that 1,000-volt architecture, which is talked about. Second, their Blade 2.0 cells. These have completely redesigned ionic channels that actually reduce internal resistance by roughly 50%. And third, active thermal management. The battery is liquid-cooled and actively preconditions itself, meaning it warms up before you even arrive at the charger. This is absolutely crucial to prevent lithium plating, which is exactly what degrades a cold battery if you try to charge it too fast. But wait a second. How does the local power grid handle a sudden 1,500 kilowatt draw? Honestly, it often can't. To prevent these massive surges from totally overloading municipal power grids, BYD integrates local energy storage, an ESS, right there at the charging pile. It acts as a 370 kilowatt-hour buffer. It basically sips power from the grid during off-peak hours, stores it up, and then blasts it into your car when you plug in. This completely bypasses the need for incredibly expensive grid infrastructure upgrades. Section 4. The real-world limitations: heat versus battery life. Now, transitioning from the slick marketing claims to independent journalism, the promise of absolutely zero battery degradation over the life of the vehicle remains, well, an unverified certainty in the real world. For example, in a live test broadcast in China, a streamer measured a scorching 76.4 degrees Celsius at the cell surface during a flash charge. I mean, that is hot enough to brew a cup of green tea. And heat is exactly what causes lithium to stop intercalating cleanly and instead deposit on the surface. It's a process called plating, which grows dendrites and permanently eats away at your battery capacity. Now, BYD has raised their warranty capacity retention thresholds slightly for these new batteries, but they haven't publicly addressed that specific heat test, so those long-term wear questions definitely still open. On top of that, field tests run by Inside EVs show that those flashy headline speeds are merely peaks. They hit near 1,000 kilowatts early in the charge cycle, but that power drops significantly as the battery state of charge increases. It falls to 767 kilowatts and then drops way down to around 463 kilowatts as it approaches 60%. So it's not a sustained megawatt blast the entire time. Section 5. Beam's off-grid alternative: zero construction, zero grid. Now, we've got to look at the exact opposite approach to this whole infrastructure challenge. Because if BYD represents this overwhelming grid-tied brute force, our next path is entirely decentralized. Let's ask a totally different practical question. What if the local grid simply cannot handle the power requirements of a massive charging hub? Or what if a location, say an airport that's operating 24/7, 365 days a year, just cannot afford the massive disruptions of trenching through their parking lots to lay high-voltage cables? Well, this leads us directly to Beam Global. Their solution is called the EV Arc, and they basically bypass the electrical grid entirely to solve the whole placement and infrastructure hurdle. These autonomous systems are quite literally dropped into a parking lot. No joke, there is absolutely no electrical work, no trenching, and no utility bills. They generate their own power through a solar array and a battery storage system, providing clean charging right where people are already parking their cars. And because these units are highly visible and completely off-grid, they unlock an entirely different business model. It's actually brilliant. The venue, let's say it's a leisure park, pays absolutely nothing up front. The power is 100% solar, meaning zero utility costs. The entire system is funded by corporate sponsorships and advertising displayed right on the units themselves. And the best part? As a result, the cost to the driver is entirely free public charging. We are already seeing this in action over in Europe. For instance, in Serbia, the insurance company Globos Osiguranje is sponsoring 5 of these beam systems at the super busy Belgrade Nikola Tesla Airport. And there are similar units at Aqua Park Rye. This proves that vital charging infrastructure can actually be expanded purely through corporate sponsorship, serving the public for free without ever even touching a municipal power grid. Finally, Section 6. 2 paths forward: the future of infrastructure. As we look ahead, the electric vehicle industry is essentially split between 2 fascinating yet highly complementary philosophies on how we're going to power our daily lives. On one hand, we've got the sheer brute force of BYD's megawatt hubs. They're mimicking the traditional gas station experience, requiring 1,000-volt architectures and massive on-site battery buffers just to tame the grade. But then, on the other hand, we have Beam Global's highly nimble, decentralized, zero-disruption solar drops, but rely on a completely different economic model entirely. So what should you take away from all this? Ultimately, the solutions to EV adoption are moving way beyond just making better cars. The real battle right now is in creative energy storage and grid management. BYD proves that a 5-minute charge is physically possible right now, and they're driving the whole industry toward a 1,000-volt standard, even if those long-term heat effects definitely need more independent testing. Meanwhile, Beam Global is out there proving that we don't always have to rely on the grid to build infrastructure. And finally, creative sponsorships can absolutely subsidize clean, free energy for drivers. It really leaves us wondering about the road ahead. Will the future of electric vehicles rely on taming the grid with massive multi-megawatt 5-minute hubs? Or will it be defined by hundreds of thousands of off-grid solar drops quietly waiting for us wherever we park? The answer is probably a bit of both. Thank you so much for joining me on this explainer. keep your eyes on the grid, or, in Beam's case, completely off it. See you next time.